7,000 years ago, in what is now Sudan, Africans built a stone circle aligned to the stars with precision that modern astronomers call astonishing. It predates Stonehenge by 2,000 years. It predates the Egyptian pyramids by 3,000 years. And it proves that Africans were tracking celestial movements, calculating seasons, and building astronomical observatories when most of the world was still figuring out basic agriculture. But you've never heard of Nabta Playa. You've heard of Stonehenge. This is the story of African astronomers who mapped the cosmos without telescopes, tracked stars across millennia, and built knowledge systems that influenced calendars you still use today. They weren't primitive stargazers. They were scientists. And the evidence is written in stone, carved in temples, and documented in traditions that predate European astronomy by thousands of years. This is Dossier number 002. Chapter 1. The Stone Circle Older than Stonehenge. In 1974, archaeologists discovered something in the Nubian desert of southern Egypt near the Sudanese border that rewrote what we thought we knew about ancient African science. Nabta Playa, a stone circle dating to 7,000 years ago. It was neither a burial site nor a random arrangement. An astronomical observatory. The stones are aligned to the summer solstice. When the sun rises on the longest day of the year, it aligns perfectly with specific megaliths in the circle. The circle tracks the cardinal directions with precision. The placement of stones corresponds to star patterns visible in the night sky 7,000 years ago. Computer modeling confirms it. This was a calendar, an observatory, and a seasonal tracker all in one. But here's what makes it extraordinary. The people who built this were pastoralists. Mobile cattle herders who needed to know when rains would come, when to move herds, when to plant and harvest. They didn't have cities yet, but they had advanced astronomical knowledge. They understood that celestial patterns repeat, that the sun's position changes predictably, that stars can tell you when seasons will shift. And they encoded that knowledge in stone so future generations could use it. Nabta Playa predates Stonehenge by 2,000 years. It predates the Egyptian pyramids by 3,000 years. It predates the rise of Mesopotamian civilization. When most of the world was still in the Stone Age, Africans in the Sahara were building astronomical observatories. And nobody teaches this. Chapter 2. Egypt's Sirius calendar. Ancient Egypt's entire civilization was built on astronomical knowledge, specifically, tracking one star, Sirius. Every year, the Nile River flooded, depositing nutrient-rich silt that made Egyptian agriculture possible. But the timing mattered. Flood too early, crops fail. Too late, same problem. Egyptians needed precision. So they tracked Sirius, the brightest star in the sky. Around mid-July, Sirius would reappear just before sunrise after being hidden for months. This heliacal rising happened like clockwork, and it predicted the Nile flood within days. Egyptians called this Wepet Renpet, the opening of the year. Their entire calendar was based on it. But this wasn't just observational. It was mathematical. Egyptians calculated that the time between Sirius risings was 365 days. Not 360, not 370, exactly 365. They had figured out the solar year length with stunning accuracy. This calendar influenced the later Roman calendar, which became the Gregorian calendar you use today. The 365-day year, the concept of measuring time by stellar events, this came from Egyptian astronomy. And it wasn't written in some lost text. It's carved into temple walls. The Dendera zodiac in the Temple of Ether shows star patterns and celestial alignments. The ceiling of the tomb of Senenmut, architect under Pharaoh Hatshepsut, depicts constellations with precision that modern astronomers confirm is accurate for 1500 BCE. Egyptians weren't guessing. They were calculating, observing, recording data across generations. This was science. Chapter 3. The Dogon Mystery. In the 1930s and 1940s, French anthropologist Marcel Griaule lived among the Dogon people of Mali. He documented their oral traditions, cosmology, and knowledge systems. What he found shocked the scientific community. The Dogon had detailed knowledge of Sirius B, a white dwarf star so small and dim it's invisible to the naked eye. Western astronomers only discovered it in 1862 using telescopes. Yet Dogon traditions described it with precision. They called it Po Tolo, the smallest, heaviest star. They said it orbits Sirius A in an elliptical path. They said it takes 50 years to complete one orbit. Modern astronomy confirms. Sirius B orbits Sirius A in approximately 50 years. How did they know? The skeptics immediately said they learned it from Europeans. But Griol's documentation was published in the 1940s and 1950s, based on oral traditions passed down for generations. The Dogon elders weren't reading astronomy textbooks. The elders were reciting knowledge encoded in their creation myths and ritual practices. Now, let's be clear. There's legitimate scientific debate about this. Some argue contamination from European sources. Others argue the knowledge is older than European discovery. Some propose alternative explanations involving ancient contact or lost astronomical traditions. But here's what's not debatable. The Dogon had astronomical knowledge sophisticated enough that when anthropologists documented it, it matched modern astronomical data. Whether that knowledge came from ancient observation, cultural transmission, or other sources, it was there, it was detailed, and it was accurate. And it wasn't the only example. Chapter 4. Great Zimbabwe's Astronomical Alignments. Great Zimbabwe, the massive stone city we've covered before, wasn't just architecture. It was an astronomical instrument. The eastern enclosure is aligned to the summer solstice sunrise. On that day, sunlight passes through a narrow gap between stones, illuminating specific areas inside the enclosure. This was marked the calendar. The conical tower, the most iconic structure at Great Zimbabwe, has astronomical significance. Its alignment and the placement of surrounding walls correspond to stellar patterns. Archaeoastronomers have confirmed that the site uses architecture to track seasonal changes. This pattern repeats across southern Africa. Stone ruins at Kami, Dlo, and other sites show similar alignments. These weren't random building choices. They were deliberately designed to interact with celestial events. Why? Because agricultural societies need calendars. Knowing when to plant, when rains will come, when to harvest, this knowledge is survival. And southern African societies encoded that knowledge in stone architecture that doubled as observatories. The builders of Great Zimbabwe were tracking time, seasons, and celestial cycles through their construction. Beyond being walls, these ruins are records carved into stone. Chapter 5. Ethiopia's Ancient Observatories. The Ethiopian calendar, still in use today, is based on astronomical observations thousands of years old. Ethiopia uses a 13-month calendar where 12 months have 30 days each, and a 13th month has 5 or 6 days depending on leap years. This system tracks the solar year with precision, accounting for the slight difference between the calendar year and Earth's orbit. The Aksumite kingdom, which flourished from the 1st to 7th centuries CE, had advanced astronomical knowledge. They tracked star positions for navigation, trade, and agricultural planning. Inscriptions reference celestial events. Architecture shows solar alignments. Ethiopia's New Year, Enkutatash, falls on September 11th, marking the end of the rainy season. This date was calculated astronomically, based on the sun's position and seasonal weather patterns observed over centuries. And it's still used. Ethiopia isn't following the Gregorian calendar imposed by colonialism. They maintained their astronomical system through millennia. This is knowledge continuity. From ancient observers tracking stars, to medieval Aksumite astronomers calculating orbits, to modern Ethiopians using a calendar rooted in that same astronomical tradition. Chapter 6. Why this was erased. When European explorers and colonizers arrived in Africa, they encountered societies with astronomical knowledge, architectural alignments, and calendars based on celestial observations. And they denied all of it. Why? Because admitting Africans were astronomers, mathematicians, and scientists would undermine the entire justification for colonialism. The narrative required Africa to be primitive, backward, and in need of European enlightenment. If Africans had been tracking stars for 7,000 years, building observatories, and calculating solar years, then what exactly was Europe bringing besides violence and theft? So they erased it. Nabta Playa wasn't excavated until 1974. The Dogon astronomical knowledge was dismissed as contamination. Great Zimbabwe's alignments were ignored or attributed to non-African builders. Ethiopian calendars were called primitive, even as they accurately tracked solar years. The evidence was always there, in stone circles, temple ceilings, architectural alignments, and oral traditions. But colonial scholarship couldn't acknowledge it without collapsing their entire worldview. Modern archaeoastronomy, the scientific study of ancient astronomical practices, has vindicated what Africans always knew. The stones at Nabta Playa are dated and aligned. The Egyptian star charts match modern astronomy. The Great Zimbabwe solstice alignments are measurable. This is beyond Afrocentric revisionism. This is science catching up to what was always true. Closing. The cosmos remembers. The same stars that ancient Africans tracked are still there. The same solstice alignments they calculated still happen every year. The knowledge they encoded in stone, tradition, and architecture hasn't disappeared. It was just hidden. African astronomers weren't primitive stargazers making lucky guesses. They were observing, calculating, recording, and transmitting knowledge across generations. They built observatories, created calendars, and tracked celestial mechanics with precision that modern science now confirms. And this wasn't isolated to one region. From Sudan to Egypt, Mali to Zimbabwe, Ethiopia to South Africa, Africans were studying the cosmos. Today, Africa continues that tradition. The Meerkat telescope in South Africa, one of the most powerful radio telescopes on Earth, is led by African scientists mapping distant galaxies and cosmic phenomena. The square-kilometer array, when complete, will make Africa the center of global astronomy. The same people who tracked Sirius 7,000 years ago are now searching for signals from the edge of the universe. That's not a coincidence. That's continuity. African astronomical knowledge wasn't erased because it didn't exist. It was erased because acknowledging it would mean admitting that Africa was always home to scientists, mathematicians, and intellectuals who understood the cosmos long before Europe claimed to bring enlightenment. The stones remember. The stars remember. And now, you do too. This is the Dossier. One truth a day until our history stands tall again.